Hello everyone, welcome to another section of Schneider Electric PLC training tutorials where you will learn Schneider Electric PLC programming. So in this lesson, we are going to understand up-down counter operation. Okay, we will see what an up-down counter operation instruction is and how to use it. Okay, so we are going to begin by understanding the function block. So just like an up counter or a down counter, an up-down counter is a measure of an up counter and a down counter. It also has the enable pin and the error notification pin, as well as the counter up pin, counter down pin, the reset pin, the load pin, the preset value pin, the current counter pin, the output down count, and the output up count. So let's see what it says. It says that this function block is used for upward and downward counting. Every pulse signal on the count up pin will increment the current counter value by 1. So if we have a pulse here, okay, the current counter value will increment by 1, and every pulse signal on the countdown input will decrease the current counter value by 1. And if we have a pulse here, then the current counter value will decrement by 1. And if the current counter value is greater or equal to the preset counter value, the up counter output is set to 1. So this output becomes logic 1. And when the current counter value is less than or equal to 0, then the down output is set to 1. So the down count output is set to logic 1. A pulse signal on the reset input will reset the current counter value to 0. And a logic 1 signal on the load pin will cause the preset input to be allocated to the output. So if we have a pulse on the load input, then the preset counter value is transferred to the current counter value. And if a logic 1 appears on the reset and the load input at the same time, then the output will be reset. So if we have a logic 1 here and a logic 1 here at the same time, then the output will be set to 0 because the reset have the precedence. Okay, so let's continue. Okay, so an important note, it says that the down counter operation only works to the minimum value of the data type being used, and the up count operation only works to the maximum value of the data type being used. Okay, so for example, if we are using a signed integer value, if we are using a signed integer value, then we can only count to the maximum value of the signed integer and to the minimum value of the signed integer. Okay, there are no overflow, that is, we can't go above or below the boundaries of the data type. Okay, you can understand that by going to the tutorials where we discuss data types and their range of values. Okay, hope that was clear. Next, let's see what we have. Okay, now we have an exercise. It says that design a PLC ladder logic program by utilizing an up-down counter block that needs to perform up to 10 counts of bad parts that need to be removed and reworked. When the parts get removed, the accumulated value increases. When the parts get reworked and get put back as good parts, the accumulated value decreases. Okay, so what does that mean? It means that we want to track up to 10 counts of bad parts, and when the part gets removed from the system for rework purpose, then the accumulated value will increase, and when it gets put back as a good part, then the accumulated value will decrease. So you can pause this video and take some time to see how you can realize this operation, then you can come back to it later. Alright, so now let's look at the solution. Okay, so this is the hardware circuit that we have made. Okay, we have considered that S1, okay, will track the bad parts, and S2 will track the good parts, S3 will reset our current counter value, and S4 will load our current counter value. Okay, and this is a ladder logic program for that. So you can clearly see that this is the sensor which tracks the bad parts. When it tracks a bad part, then a pulse will come on the count up pin and our current counter value will increase. Okay, like it was said in the problem situation. And when we detect it as a good part, then it will decrement. Okay, so there will be constantly increment and decrement. So a bad part will increment it, a good part will decrement it. And we have up to 10. Okay, we want to track up to 10 counts. All right, and the reset will reset the current counter value to 0, and the load will transfer the preset value to the output. And we have now a pusher. This is an actuator to push out the bad part. So when it detects a bad part, you can see that this logic becomes true and a logic pass. And when the logic pass, this coil is large and this coil is attached to X, which is our pusher, which can push out the bad parts for it to be reworked. Okay, so let's test this logic in our software. So I'll open my Schneider Electric software. Okay, so I've already pre-created a project. You can do the same. Okay, and these are our variables which I've created. Here I'm using memory, okay, memory locations to do that. And remember, when we are using memory location, we can replace them with any address of our choice. Okay, so what I'm just going to do now is to change them to eBooks for compatibility issues. So if not, we are not going to be able to compile the project. All right, we have now changed all of them to eBooks. So I will go to my project right now. I'll go back to my project. You can see we have already constructed a circuit. All right, this counter up down, you can get it from the library by just going to the library like that, and you can type it out here, CTUD. Okay, so it has come up. You can now just drag it and drop it in your environment. Okay, like that, and you can now start wiring it up. Okay, all right, so I will now analyze my projects. You can see we have no errors. I can build a project. I will now transfer. Okay, I'll first of all connect. So I will transfer my project. I'll start my simulation. Okay, good. So you can see the down count is already large because the current counter value is 0 or less. Okay, so what we want to first of all do is we will assume that, but before then, let me initialize the animation table. Okay, so I hope this is now visible. Okay, so first we are going to assume that we have detected a bad part. Okay, so I'll put them under the first mode. We'll assume that we have a bad part. Okay, so when it goes high, okay, we have detected a bad part. The counter value has accumulated to 1, and now the pusher is active. And when the pulse goes away, the pusher is reset, and we can constantly be counting up and down. Okay, so we are now at 4. We can be counting up and down. We are now at 5. Okay, so you can clearly see that none of these outputs are high because the preset value is the current counter value is neither greater or equal to the preset nor less than 0 or equal to 0. Okay, so I will progressively increment it. Okay, and if I decide now to assume that we have a good part was detected and it goes high, you see the good part does what? The good part should constantly decrement that. Okay, so you see the good part constantly decrements it, and the bad part will increase or increment it. Okay, constantly increment it like that. All right, and when it is now 10, then we want to indicate, okay, with the count of that we have reached 10. So I will determine good parts, bad parts up to 10. Okay, so it's now 10 and above. You can now see it has now detected that we have detected up to 10 parts. All right, good. So if I now take the reset button, it should set this current counter value to 0. So this is a reset. I will set it to high. So the current counter value goes back to 0. Okay, So this is what we're saying, that our counter will reset when I press this. And if I go to the load terminal and I load it, then this value 10 should go to the output like that. Okay, so the reset has a precedence. The reset is still on. I'll put the reset off. Set it off, and now I will load it to the output. Good. So you see, I've sent a logic signal on the output, and it now goes to the output. And it's now 10. That is why we have this as logic 1 at the kilo output. Okay, I hope this was not complicated to understand. You can download it, test it, it's going to work. The same, this is our actuator. Okay, all right, good. So let's go back to our presentation. All right, so that will bring us to the end of the up-down counter instruction. So let's see what we have understood. So this function block is used for upward and downward counting. Every pulse signal on the count up input will increase the current counter value by 1, and every pulse signal on the countdown input will decrease the current counter value by 1. When the current counter is greater or equal to the preset, then the up output is set to 1, and when the current counter value is 0 or less, then the down output is set to 1. And a pulse on the reset input will reset the current counter value to 0. A logic 1 signal on the load input causes the value of the preset to be allocated to the value of the current counter. And if we have a simultaneous 1 on the reset and the load pin, then the reset has a precedence, so the current counter value will be set to 0. Okay, hope that was easy to understand. Okay, so thank you very much for watching this video, and in the next video we are going to be looking at timer operations. And please, if you like this video, please give it a thumb up, share it, and subscribe so that you don't miss any of the upcoming videos. And if you think that this video needs any improvement, please share it with me in the comment section down below. Okay, so see you in the next video.